Let's make one thing clear. It's impossible to defy the laws of physics. Everything operates within their boundaries. However, modern physics is full of intriguing quirks, and there is still so much we have yet to comprehend. Sub-inventions, like the warp drive, have challenged us to reconsider long-established laws of physics. Let's delve into these fascinating discoveries now. Number 10. Vacuum cleaners can lift cars. The famous Mythbusters team set out to test how effective a vacuum cleaner could be at picking up heavy objects. After successfully lifting lighter items, they aimed to see if they could lift a car. Sounds unbelievable, right? Well, it's not, because lifting power increases linearly with the cross-sectional area of the attachment as long as the same amount of air is being removed at the same rate. The Mythbusters built suction cups that covered a large area, enabling them to lift much more than the standard attachment, which could only handle 5 pounds or 2.3 kilograms. The team constructed 40 suction cups, all connected to a single vacuum, and managed to lift the car to the crane's maximum height. Some mathematicians believe that a human could lift a car with a big straw if they could achieve a tight enough seal and a large enough attachment area. Now that's something we all like to see. Number 9. Perpetual motion machines. The idea behind perpetual motion machines is that you can set them going and they will continue in motion forever. They have been a curiosity to inventors as they'd solved many issues associated with energy loss in mechanical systems. Perpetual motion machines date back to the 1600s when Robert Flood's 1,618 water screw was developed to rotate a milestone continuously by pumping the water that powered the machine back to its own tank. The same body of water would then continuously run the machine. You don't need a fresh supply. Another machine named the Macintosh wheel utilized magnets to help it spin seemingly forever. And now we can make refined versions of this with neodymium magnets, which could rotate for years. The time it takes for the magnets to lose their attractive force, however, sends energy can neither be created nor destroyed. These machines can't technically produce energy on their own, they just seem like they can for a short while. For example, the water screw would lose energy due to friction. True perpetual motion machines are impossible as they violate the first and second laws of thermodynamics, which essentially state that energy must come from somewhere and cannot be created without input, and also that a mechanical system will eventually move towards a state of this disorder and thus will eventually cease to function. Number 8. Dipping hand into lead. Molten metal is hot, but molten lead isn't as hot as you expect, only 327.5 degrees centigrade. Still, it seems ridiculous to suggest that you can dip your hand at molten lead briefly without injury. You'd expect to be burnt instantly, right? If you dipped a bare hand into the molten metal, then yes, this would definitely occur. But a thin layer of may be enough to protect the hand for a short time. This is due to the lead and frost effect. When you dip an object coated in water into a hot liquid, the water boils and evaporates very quickly, forming a protective layer of steam. This can actually protect a human hand when dipped in molten lead. Of course, the effect is temporary, and leaving your hand in the metal for anything longer than a tiny fraction of a second will likely result in your hand being maimed. Number 7. Warp drive engine. The challenge of space travel has always been a top priority for many of the world's most advanced technology developers. Today, with the advent of reusable rockets, travel within our solar system has become relatively efficient. The technological frontier now extends to interstellar travel, enabling us to venture to new solar systems in search of a new Earth. However, traveling to some of the nearest and most promising exoplanets, such as those in Proxima b, poses significant challenges. Even if we could travel at the speed of light, the journey would still take over 80 years. Current spacecraft, traveling at around 84,000 kilometers per hour, which is a tiny fraction of the speed of light, would take approximately 54,400 years to reach systems like Proxima b. To achieve stellar travel, we need to overcome the limitations of classical physics, including Newton's laws of motion. One proposed method is the warp drive, which compresses time in front of a spacecraft and expands it behind, manipulating spacetime around it. This method shortens the distance between points A and B while traveling in a bubble that compresses vast interstellar distances. Initially seen as outlandish, the concept has gained traction as both NASA and the Chinese Space Agency have tested devices that create thrust without fuel by bouncing microwaves around chambers. Although the exact mechanism behind these results is not yet understood, these tests hint at the possibility of overcoming current limitations and achieving interstellar travel. Number 6. Spin Top Toy. A spinning top seems like such a simple thing, one of the simplest toys ever invented in fact. The tippy top, however, is a little bit more odd. It's a type of spinning top that goes the opposite way to a normal one by inverting itself after spinning upside down. It gains momentum until it reaches a critical point and then spontaneously inverts itself. That's pretty cool in itself. But the tippy top developed by Tadashi Tokita is a bit more confusing. This tippy top acts in the way you expect when you spin it in one direction, but when you spin it in the other direction, it seemingly fails to behave in the way you'd expect it to. So, why does it have a preference? This Harvard scientist admits that no one really understands why this occurs with the toy, but it has something to do with the neutrality of the spin top. Chirality explains how mere image shapes can have different properties despite their apparent symmetry. For example, its weight or some of its molecules or ions may be asymmetric across its cross-section. Number 5. Space Elevator. Traveling from the surface of Earth to space currently requires the use of rockets. Today, rocket launches are relatively efficient, but SpaceX's latest rocket still required energy equivalent to 4 million tons of TNT to launch. Basically, then, there is a huge demand for slicker, cheaper, and simpler methods for getting a lot of stuff and satellites into space. One proposed solution is by building a space elevator, which extends beyond our atmosphere. This enormous structure is essentially a cable which stretches from the surface of Earth to space and would allow us to transport supplies into space without the need for rockets. The primary issues are strength and flexibility. Such a structure would have to flex with the Earth's rotation, and it need to be enormous 100 kilometers or so tall. Originally, carbon nanotubes were thought strong enough, but now diamond nanothreads could be the key to space elevator technology. Best of a giant Japanese construction company believes we could have the technology to manufacture an elevator of this size using this material by 2050. Number 4. Square wheels. Triangles, squares, octagons, hexagons, none compare to the mighty wheel, regarded as one of early humankind's greatest inventions. It's counterintuitive to think that a square wheel would do anything other than wreck a vehicle. The Mythbusters decided to test whether it was possible to achieve a smooth ride by driving a car with square wheels, a seemingly impossible task. Initially, they attached 4 square wheels at the same angle, resulting in a horrifically bumpy ride with quickly braking axles. However, by adjusting the angles of the wheels so they were at 22.5-degree angles to each other, the points of contact between the square wheels and the ground occurred more frequently, resulting in a smoother ride. By driving fast enough, they managed to achieve a semi-tolerable ride with square wheels in this configuration. The team also investigated whether square wheels would provide any advantage in hill climbing, but they found no benefit to using them. Number 3. Sailboat propelled by onboard fan. Out of all of the quirky experiments out there used to illustrate how simple laws of physics, like Newton's laws of motion, are more complex than they seem. This one can really get you scratching your head. In a normal sailboat, wind hits the sail in the direction of travel, filling the sail to then generate thrust. So how could you generate thrust in a sailboat without wind? Here, Mythbusters show how a fan can be used to propel a sailboat. This is counterintuitive. Think about it. The fan has to blow against the sail. This means it is pulling air from behind the boat and pushing it to the front of the boat. This means we expect the boat to travel backwards. The opposite direction to air traveling through fan, but despite this, if you place a sail in front of this fan, the sailing boat instead goes forwards. This seemingly contradicts Newton's third law, which would state that the boat should move in the opposite direction from the direction the fan's intake. What is really happening here is the fan generates a force which strikes the sail, and then some air rebounds backwards off the sail, propelling the sailing boat forward. So Newton's third law still applies. The boat is moving away from air that is reflected from the sail. Still, if you actually want to move fast, it's much more efficient just to point the fan out the back of the boat. Number 2. Venting bullets. The elusive ability to fire bullets from a weapon whilst hidden round corners or obstacles was researched during World War I. And the Krumov was developed as part of the Nazis' rather large effort to innovate their weaponry, suggesting that a bullet which travels at 1,000 feet per second can be bent in a matter of a couple of feet seems a bit ridiculous. You may speculate that the bullet would just conform to its straight path and penetrate through the barrel itself, but you'd be wrong. The Nazis were obsessed with experimental weaponry, but this device, unlike many others, at least partially worked. It used carefully placed holes to disperse turbulent gases. It enabled the Sturmgewehr 44 to fire rounds over obstacles or round corners, but the challenge was retaining accuracy and reliability. Many prototypes simply didn't fire or blew up until eventually one was developed, which worked at close range. The bullets would often disintegrate due to the higher pressures of gas within the barrel, and the barrel itself only had a lifespan of a few hundred rounds. Taking this to the extreme, a bullet will even fire with a 180-degree barrel. The unusual thing about doing this is it still recoils but forward like it's being pulled away from you. Today, more advanced weapons like the Israeli corner shot enabled this via the use of a digital camera attached to a bendable detachment with a pistol attached. Number 1. Driving motorbikes and cars on water. If vehicles could effectively drive over water, there'd be no need for bridges or crossings. While this isn't truly possible, we can temporarily force land vehicles to traverse water. For instance, a normal, unmodified motorbike can travel a few hundred feet on water, but it requires substantial speed to do so, taking advantage of water's surface tension. With cars, the results are less impressive, but with enough speed, a car can effectively skip over a few meters of water. The car bounces off the surface, allowing it to travel forward just far enough to clear the water. This demonstrates some intriguing and confusing aspects of physics. This goes to show that the laws of physics, often seen as concrete and basic, behave in more complex ways than we commonly understand. Which experiment did you find the most interesting? Let me know in the comments below. Thanks for watching.